Greetings, friends. It's May 14th, 2025. Going to do some updates. You're possibly a longtime follower of this literature. I won't say necessarily this YouTube channel, although that's possible as well, of course. But by this literature, I mean a sort of a futurism that emphasizes our artifacts, like less how should we all live in terms of government, because that's up to the locals, whoever you are. You're working on some experiment probably, but low barrier to entry as far as getting some dwellings together, getting some community off the ground. And experiments don't have to last forever. It's too often counted as a failure when, say, a company like a filmmaking company, they come together to make that film, which is more than just making the film. There's promoting the film. There's sticking around until the film is launched and well on its way and safely archived, and maybe it's shown once already in theaters. But at some point, that company is ready to move on and it can just dissolve. It doesn't have to make a next film. So there's an emphasis as we plan these prototyping communities under the heading of what I call Epcot West. Here out in Cascadia, we're following, tracking, aware of our indigenous companies, but also global companies that are situated halfway around the world that have products of interest to us. We track these things. And the idea is that the community is going to have turnover, both in personnel, but also in which exactly prototypes are we showcasing. They'll come and go. It's not like the permanent suite. Some will stick around. Some will prove old favorites. Some will be swapped out. The point of some of these models is their A, deliverability, but then B, movability or recyclability. And I was saying in a meeting today, I think it's going to be along the lines for many businesses of appliance companies, where at the retail level, let's call it, you swap. In other words, they take the old washing machine when they bring the new one. They take the old dishwasher when they bring the new one. So they'll take the old pod, the tripod, whatever, and swap it out for the next generation. Let's model it that way for now. And the community as a whole may be designed to disappear at some point and vanish without a trace. Sort of a rule of thumb with scientific research when you're going into an ecosystem to learn as much as possible in an effective amount of time. You're not planning to make a permanent impact and like forever change what you found there. On the contrary, you're wanting to observe without disturbing. That's a goal you have. It's not always the case. I'm not saying this is like across the board what all engineering is about. Oftentimes, you're there to disrupt or do something changey, but a lot of times we just want to leave things as they are, and this means at the community level, we may be disbanding or retracting, pulling out our base without leaving a trace. A base with no trace, that's something to shoot for in many contexts. So that's at the level of physicality, you could say, larger prototypes, sort of the Burning Man soundstage, sprawling asylum cities, refugees coming and going, pilgrims coming and going, and professional prototypers like test pilots, people who aren't expecting all the comforts necessarily in the first iteration, but somebody's got to try it, somebody's got to critique it from an informed point of view. So we have people coming to our communities who've been to other communities before this, and they're used to, like car magazines. You drive it, you test drive it, and then you write about it, and you say what it feels like. And this is going to happen in the dwelling area. In other words, this thing's not ADA compliant, or, this is it's too loud at night, the rain, it's just deafening, whatever. many critiques and praise and so forth. So connoisseurs of lifestyle, that will be in itself a lifestyle. So that's looking ahead, planning that with Caltrop City today in a meeting, and then thinking about curriculum in a more metaphysical sense, getting back to computer science and so forth. We've put quite a bit of work into this Quadcraft project notebook, which is also driving software development for real. We have a software developer, a game developer who knows a lot about putting code right in the web page so that you can just download the raw HTML file and run it locally on your computer and see what's up. So we demoed that today, and I use the word demo advisedly because the whole theme of this notebook is we have the specific mathematics involving quadray coordinates, which we want to demo to the planet and do so in a very cogent way. That if you read source code, it's like, oh, I see what you're doing there. And a main thing that we're doing is converting back and forth to ordinary XYZ coordinates because all of our APIs to like 3D game engines, OpenGL, Unreal, all these different Blender, all these different real-time rendering machines are of course driven by XYZ coordinates. And that's not really an issue, it's fine. It's just with quadrays we want to foreground a four-tuple based way of labeling positions that will give all the CCP spheres in a sphere packing integer addressing. Not only that, but positive or non-zero, non-negative. You in the canonical way of doing quadray coordinates, we do have a zero there, at least one zero there always, because there's always one quadrant of four that, in other words, there's always a vector pointing away from outside of the quadrant that we're in. There's four quadrants as defined by four basis vectors from the origin, 0, 0, 0, 0. And I give you a random point in space vis-a-vis this origin. It's going to be in one of four quadrants. And you can map those points in that quadrant using the three bounding axes. You could call them bounding vectors similar to as an XYZ. Except in XYZ, we have 90 or 180 degrees between our spokes. And by spokes, I mean positive negative X, positive negative Y, and positive negative Z. It makes like a jack, like an octahedron, like crisscross in 3 dimensions, as we call them. So with quadray coordinates, it's 109.47 degrees between any two axes. And so instead of dividing space into 8 octants, we divide it only into 4 quadrants. And there's always going to be an arrow pointing directly away from whatever quadrant we're trying to map a point in. So I'm giving you an intuitive reason why, as a formal canonical representation, we chose to have a 0 for the dormant vector, you could say, and then the other 3 are active, but maybe it's on an edge, or maybe it's 2 zeros or 3 zeros or 4 zeros, but always at least 1 0, and the rest, if not 0, then positive. And in the case of CCP balls, cubic closest packing, linear combinations of 2, 1, 1, 0. So 2 of one of the vectors, 1 of 2 others, and none of the fourth, as we were saying. There's 12 ways to do that, and those point to the corners of a cuboctahedron, which is what I'm showing here in this animated GIF. And although this notebook is about demos that would be off stage, so to speak, there is kind of the built-in demo of just the framework that I'm using for these stills or animated GIFs. That too is driven by the math that we're trying to showcase here. So If you don't have anything else to show, you could at least show this framework, but you don't have to show this framework. You may have other things to show instead, like what we're working on in the background here at the GitHub site and so forth. And it may or may not have turtles, or, it's like how closely it follows the specs of the default implementation. We shall see. We're at the early stages of this. Basically, I'm predicting that game developers will want to sort of benchmark themselves against this kind of quadre thinking just to get into the mood to use the synergetics namespace more, which includes the volumes table here. In other words, synergetics constant, you know the drill. If you've been reading the literature, as I say, the literature including, basically Pound era. If you're fluent in 1900s poetics, you've read synergetics. If you haven't read synergetics, then some more fluency might be helpful to understand what's going on in the 21st century, the 2000s. Because a lot of us did study it, and we do see how it's applicable, and we're moving forward quickly with the open source revolution, or design science revolution, as you want to call it. Either way, it gets a lot of engineering attention. And maybe intellectual property lawyers aren't that into it because it is so open source, right? We have less need for their services. So that might be why you don't know much about it, because you hang out more with lawyers than engineers. I don't know. It's a cultural thing. But it's raging out here in Cascadia because this is Silicon Forest. Silicon Forest goes up to and includes, like, Seattle, Bellevue, down to, there's no precise boundaries that we have to talk about. But place-based, right? It's like our synergetics has the flavor of the Cascadian bioregion, which is very intensively Native American as well. All right, good chatting with you. See you in the next video.